So we left off with example 16. So find the numbers b such that the average value on the interval is equal to 3. So I'm trying to figure out where should my interval stop so that the average value of my function is equal to a height of 3. So let's take a look. Okay, so what I need to do first is I need to identify the average value again. And I'm going to pause here, or encourage you to pause here and think again, what's the difference between, or what is average value mean? Okay, if you're struggling a little bit, leave yourself a note. What's the difference between average value or average rate of change? Okay, so this is average value. That's just like trying to figure out the average on your test. You'd add up all the scores that you got and divide by how many scores you had. So what that looks like mathematically is I actually put the divide by how many scores you have first. So we would have, how big is our interval? It goes from 0 to b. So we would have b minus 0 number of scores. And then adding up would be the sum from 0 until b of my function. 2 plus 6x minus 3x squared. Don't forget your dx. Now this is something that we want to end up equaling what? 3. So we want this average value, which is what this calculates, we want that to be equal to 3. So let's do a little bit of algebra here. Let's start to clean up what we can. So 1 over b minus 0 is 1 over b. Let's integrate this thing. The integral of 2 is 2b. No, my bad. 2x, because we're integrating according to x, plus 6x squared divided by your new exponent, minus 3x cubed divided by your new exponent. And that's going from 0 to b. This is supposed to equal 3. I ran out of room, so I'm going to bump over here. Okay, so I've got my 1 over b out front, multiplied by, and my first quantity is the first part of the fundamental theorem. I'm going to plug in b first, and then I'm going to subtract this one. So that's going to look like 2b. Let's clean this up. 6 over 2 is 3. B squared, 3 over 3 cancels, minus b cubed, minus, the nice plug in 0 for all those, you'll get 0. This is supposed to equal 3. Try to clean it up a little bit more. I am going to distribute this in. I don't care about that 0 anymore. So 1 over b times 2b is 2. 1 over b times, that's going to cancel out a b. That's going to cancel out a b. All right, how would you solve this? Hopefully you said ZPP, factor in ZPP. So I'm going to try to get everything to one side. Because this is negative, I'm going to choose to move this way. So 0 equals, bump that over, that's b squared. Bump that over, that's minus 3b. Bump the 2 over, that's plus 1. Why am I groaning? Because this obviously doesn't factor, which means then we need to do our good friend. X equals negative b plus or minus the square root of a squared minus 4ac all over 2a rah. Now remember, this is solving for b, not x. So I know it's getting kind of confusing, a, b, and c. Hopefully it's not too bad. So it's negative b plus or minus b squared minus 4 times a times c all over 2 times a, which we can then clean up. B equals 3 plus or minus 9 take away 4 is 5. My math voice is very happy because that's not clean upable. There's no perfect squares that go into 5. Okay, now before I box these in, make sure they make sense for our interval. Because even though we could take an integral from 0 to a negative number, you can't have an integral that starts at 0 and goes to a negative number. So are these both positive values? Well, let's do quick. What's 3 plus root 5? Positive. Divided by 2 is still positive. What's 3? What's 3 minus root 5? Well, that gets a little stickier. Well, root 5 is a little bit bigger than root 4. but it's not as big as root 9. So root 5 is between what two numbers? Hopefully you said 2 and 3. So 3 take away something between 2 and 3 is still going to be positive. So both of these guys are in. Both of them are positive. I'm going to leave a little note for myself for next year. Double check that they work for our interval. Double check that they work for the interval. All right. Okay, so I'm guessing you should be able to do the next two on your own. So we'll obviously do one at a time, but let's have you try to do example 17a on your own. All right, let's see how you did. So again, find the condition. So I want to solve this thing. That means I'm going to integrate this. I'm going to figure out when this thing equals 0. So just like we did up here. So I'm going to integrate from -3. So let's integrate t cubed would be t to the 4th over 4 minus 7t squared over 2 from -5 to x. And I want that to equal 0. So now this is something that I can compute. So let's now start plugging in a chugging. So this is the quantity of x to the 4th over 4 minus 7x squared over 2 minus, because I'm doing plug in, then subtract this one. Then I've got -5 to the 4th over 4 minus 7 times -5 squared over 2. I'm already hating this problem, but we can persevere here. Let's get rid of the parentheses and try to clean up a little bit. So let's go with x to the 4th over 4 minus 7x squared over 2 minus, okay, distribute. That negative is going to get squared out. So what's that? 25 and 25 is 625 over 4. Okay, this is going to be a negative. That's going to be a positive. So this is going to stay a negative, but we're distributing this negative. So that's going to be a positive. Okay, so this is really 25, right? So we're really doing 7 times 25. So I always think about 25s as groups of 4. So I've got one full group of 4 and 7. So that's going to be 100. And then I've got 3 groups of 25. So that's going to be 75. So that's 175 over 2. I could try to get a common denom here, but I'm just going to try to kill everything off at this, all the fractions off at this point. So I'm going to multiply the whole equation. I mean, technically, I'm doing both sides. So this is AP. We got to be a little fancy. Times everything by 4 to kill those fractions. So I would have x to the 4th minus, okay, the 4 is going to cancel, but it's going to still have a 2 there. So that's going to turn, right? The 4 divided 2 times is going to make a 2, and 2 times 7 is 14. The 4 is going to cancel, minus 625, plus the 4 and the 2 reduces. 2 times 175, that's 270 plus another, so 350. Does that sound right? Hopefully. Yeah. 4 times 0 is 0. Combine like terms, x to the 4th minus 14x squared. Go over the margin if you can't do it. That'd be 350 would be 700. Ugh, I can't do it. So I'm going to go 625 minus 350 and then just switch the sign around. That's 5, that's 1, that's carry, that's 5, that's 7, that's 275. So minus 275. Oh, look at your factoring style. I wish that was x squared and x, but we still have this pattern. Remember what we called this last year? What kind of factoring is it when it goes x to the 4, x to the 2, or x to the 10 and x to the 5, or x to the 50 and x to the 25? This is what we called weird. So it's regular factoring, but it's going to make those things squareds. I had to cheat here, so I'll admit that I had to do some calculator stuff. So I did 275 I broke it down into 11 and 15. My bad, 11 and 25. Let's try that. That's better. 11 and 25. So then I'm going to have as my factors. So what kind of, I need negative 14. So I need the 25 to be negative. I need the 11 to be positive. Now we would finish these from here, and these are fairly easy to finish. So x squared, ZPP that, bump over the 25, or just keep factoring. We'd get x equals plus or minus 5. Then I bump this over, I'd get a negative. So, unless we had imaginary, which we wouldn't, that would be plus or minus I root 11. But I'm not even going to box that in. This is what our answer is going to be. Okay, now let's talk about this graphically and why it seems to make, or it should make some reasonable sense. See if we can get a rough sketch, a real rough sketch of this function. So we know it's a cubic. So in our head, we should be able to picture what cubics look like. I'm going to actually factor this. So I get t times t squared minus 7. So now look at when I ZPP this, I'm going to have 3 intercepts. I'm going to have one at 0. And then I'm going to, if I ZPP this, bump over the 7 in square root, my other 2 are going to occur at root 7 and negative root 7. So those are going to be my intercepts. So t was positive, so my function needs to, you remember what a end behavior of a cubic looks like with a positive. This side needs negatives head negative, positives head positive. So my graph's going to look something like this. Now, if it's exact, I don't know. But let's talk a little bit about why these answers seem reasonable. So I know this doesn't really fit very well, but I'm going to stretch it out, just squeeze it down, just to make it easy. Because where does our integral start? Our integral starts from negative 5. So here's negative 5. Now, we're trying to decide how far should we move on the x-axis. So the area under the curve, we're accumulating, and it should equal 0. Well, how far should we go to get an area of 0? First thing we should do is not go anywhere, right? If I start at negative 5 and end at negative 5, how much area have I created? 0. So this answer makes total sense. Now, how far would I have to go before I get another area of 0? Well, basically, as we go forward, this area right now is negative, negative, and then positive. But those aren't going to be the same areas, or at least we can't tell. But as we keep going from here, as we could tell, this is an odd function. Now look at these two areas. Those cancel out. And as I keep going, how far would I have to go? Well, from the negative root 7, I needed to go to negative 5. So from the positive root 7, I would need to go to positive 5. So those two answers should make graphical sense as well. Because, if you're starting at negative 5, if you don't go anywhere, you automatically have an area of 0. And then you'd almost have to go to the other extreme to be able to get that value. Now, that's because we're odd and some interesting things happen there. So let's try this one. Have you try it again, see if you can find the two solutions, and then we'll talk about what it looks like graphically. Or actually, let's talk about what it looks like graphically first. Let's try that. So make a sketch. Make a little sketch. Try to draw it over here this time. Okay, so I'm going from negative 3, so 1 to negative 3, until some value down over here. I don't know where that is. So tell me about this function. I know it's a parabola. I know it's a parabola that shifted down 4 spots. 2, 3, 4. So let's get in a real rough sketch. Over 1, up 1. Over 2, up 4. 1, 2, 3, 4. Over 3, up 9. So that's another 5 since there. So I can then kind of mirror this, not kind of, absolutely mirror this on the other side. So let's try to figure out how many solutions we're going to end up having here. So I'm starting my interval at negative 3. Well, the first thing I should do is not go anywhere. Just stay there at negative 3. That would find me an area of 0. Then as I move in, this area right here is all positive. So there's going to be somewhere, I don't know exactly, I don't know if it's going to be exactly right here, but there's some place in here where those two are going to cancel each other out. So I'm just going to put a little check mark maybe, that there's going to be some solution in there. And then as I keep going, I'm going to get a bunch of this negative area. And then somewhere down the line, now remember, I just stopped my graph here, but this graph keeps going. I'm going to keep, I know it doesn't look like that, but it goes over and over and over. So at some point, this little positive with this big negative is going to get canceled out with some positive amount on this side as well. So we just need to figure out where so I think this thing's going to have 3 different places. Don't move at all. Move a little bit where you have positive and negative, and then you're going to take this positive, this negative, overall is going to be negative, right? When you add these two areas together and treat this as a negative area, then you're going to go some distance down here that's going to create another positive. Now, maybe it's exactly the same like this one was, where it's 5 and negative 5, same gap, but I guess we'll have to wait and see. Okay, so go ahead, pause it, and try to integrate this, solve this for x. Okay, let's see how you did. So I'm going to integrate first. So that's x cubed over 3 minus 4x from negative 3 to k. I want that to be equal to 0. Now I can start plugging in a chugging. So that's k cubed over 3 minus 4k minus, let's do that in our head. That's going to be a negative 27 over 3, so that's a negative 9. Let's do that in our head. That's going to be a positive 12 equal to 0. Start to clean this up. I'm going to get k cubed over 3 minus 4k. Okay, that's negative 9 plus 12 is 3, but it's a subtract. I don't like that I've got negatives, so I'm sorry, that 1/3, so I'm going to kill that off next. Multiply everything by, it should get fancy, times by 3 times by 3. So I would get k cubed minus 12k minus 9 equals 0. Now, when I first did this problem, I did the quadratic formula. Oh, I wish that cursor, sorry if that cursor is right in the way. First time I did this problem, I then did the quadratic formula next. And that's no good here because this is k cubed, not k squared. So let's do all right, do we already know? So we've got to find what we can do, though, is if we can find one solution, we could knock this equation down by one exponent. So if we look up here, we already graphically figured out that there's going to be definitely one solution. The solution of negative 3 is going to work. So if I know that negative 3 is a 0 of this, or a solution to this, what can we do to find the other ones? Well, we can do our synthetic division, which we haven't done in a long time. So I know negative 3 works. What are my coefficients? 1, 0, negative 12, negative 9, because you got to remember, you got to account for every term, even the ones that aren't there. 1 drops, that's negative 3, that's negative 3, that's positive 9, that's negative 3, that's positive 9, that's 0. Which means now we have the equation k squared minus 3k minus 3 equals 0. So one of our solutions is right here. So don't lose it. I'm going to actually circle it. K equals negative 3. We knew that would work right off the bat. Now we're going to find our other two. Factoring is out. So we're up to our good friend, the quadratic formula. So k equals negative b plus or minus b squared minus 4 times a times c all over 2 times a. So we get 3 plus or minus negative 12 plus 9, so that's 21. I like that. No perfect squares going to 21. So we can't clean that up at all. So where are our solutions? Remember, we said that we were probably going to find 3 solutions. We would solve that k could be equal to negative 3 or 3 plus or minus root 21 over 2.